Chapter 10, Section 1, the Pythagorean Theorem. What does the Pythagorean Theorem do? The Pythagorean Theorem helps us find missing side lengths of right triangles. And it says only because the Pythagorean Theorem can only be applied when you have a right triangle. So if you have an acute triangle or an obtuse triangle, the Pythagorean Theorem is not going to work. Only for a right triangle, which means it has one right angle. Parts of a right triangle. Notice in this yellowy orange triangle, I have a right angle, which is notated in blue in the bottom left corner. The two sides that form the right angle are called the legs of the triangle, and then the side that is opposite the right angle is called the hypotenuse. A little trick that some students have told me that they've learned before is if you create an arrow with your right angle, it's going to point at the hypotenuse, which just means that it's opposite or across from the right angle. One thing that I wanted to take note of really quickly is that the hypotenuse is always going to be the longest side. So if you just have three numbers, the largest number is always going to be the length of the hypotenuse of a right triangle. The Pythagorean theorem is a squared plus b squared equals c squared. A and b are the two legs of the right triangle, and c is the hypotenuse, which we just said is going to be the longest side, or the largest number. The first example says Anita is tiling the backsplash of her kitchen with triangular pieces of tile. If the sides of the triangle are 3 inches and 7 inches, how long is the triangle's hypotenuse? The first thing that I want to address in this problem is the fact that because the triangle has a hypotenuse, we can say that it is going to be a right triangle. It never says that you have a right triangle outright, but because it says how long is the hypotenuse, we know that it's right because only a right triangle has a hypotenuse. We know the missing side would be c in the Pythagorean theorem because the missing side is the hypotenuse. That's the side length that they're asking us to find. So we're going to plug in 3 and 7 for the legs, or a and b. I plugged it in as 3 squared plus 7 squared equals c squared. It does not matter the order that you plug in the legs. I could also say 7 squared plus 3 squared equals c squared. The thing that is important is that you're adding the squares of the two legs and you're setting that equal to the square of the hypotenuse. So the order on the 3 squared and 7 squared could be switched around, but they have to be adding together on one side of the equal sign. The first thing you do when you have the Pythagorean theorem and you've plugged in what you know is go ahead and square the numbers that you've plugged in. 3 squared is 9, plus 7 squared is 49, and I can't square c because I don't know the value of c. Go ahead and add 9 plus 49 because they're being added on the same side of the equal sign. So I would have 58 equals c squared. Something that you maybe have talked about before, maybe not, is that we do not have c isolated or solved for c yet. In order to solve for c, I need to get rid of the squared. In order to get rid of a squared, I need inverse operations. Remember, the opposite of addition is subtraction, the opposite of multiplication is division, so I need something that is opposite or the inverse of squaring. And that is going to be, the inverse of squaring is taking the square root. Just like when you're solving any other equation, whatever you do to one side of your equation, you have to do to the other to keep it balanced and equal. So I need to take the square root of c squared. Because I'm taking the square root of the right side of my equation, I need to also take the square root of the left side, which is 58. Plug this into your calculator. This is not what we call a perfect square. When you take the square root of a perfect square, your answer is going to be a whole number, and 58 is not going to be a perfect square. A whole number times itself is not equal to 58. So plug it into your calculator, and you should get about 7.6 inches for c. Really quickly, that would make sense and that could be a possible length because we know that c, or the hypotenuse, the missing side that we're trying to find, has to be larger than both of the two legs. So one of the legs was 3, one of the legs was 7. So 7.6 does work because it would be the longest length of the sides. The next example says, what is the side length of B in the right triangle below? Notice we have 7 as a leg and B is a leg, and then the hypotenuse, or the side opposite your right angle, is 25. So when I plug in what I know, I'm going to say 7 squared plus B squared equals 25 squared. Again, I could have B squared plus 7 squared. It's not going to change my answer. Go ahead and square the numbers that you have. 7 squared is 49 plus B squared equals 25 squared is 625. In this case, I still need to solve for B. I still need to get it by itself, but now I'm going to have to use inverse operations to get rid of 49 first. In order to get rid of a positive 49 being added to B squared, I need to subtract 49 from both sides, and when I do so, I get B squared equals 576. Just like before, I'm not done yet. I need to get the squared. I need to get rid of the squared. In order to get rid of B squared, I need to take the square root of both sides. When you plug in the square root of 576 into your calculator, you find that this one is a perfect square because the square root of 576 is 24. The next example says the next thing we need to talk about is that when we're given 3 side lengths. So when we're given 3 side lengths and they're asking us, is this a right triangle? We're going to plug the numbers into the Pythagorean theorem. The largest side length has to be the hypotenuse, or the c, in a squared plus b squared equals c squared. If you get an identity, then we know that the 3 side lengths are forming a right triangle. An identity, just a reminder, is when you get a number or variable equal to itself. So if you got 7 equals 7, 36 equals 36, 100 equals 100. Those would be identities, and that's going to mean that we do have a right triangle. If I wind up with something like 3 equals 25, well, 3 does not equal 25, so the Pythagorean theorem is not true for those 3 side lengths, which means it is not a right triangle. This last example says, which set of lengths could be the side lengths of a right triangle? This time they've given me all 3 side lengths, and I just have to apply the Pythagorean theorem to these and see if they are I get a true identity or I do not. So for A, I have 5, 8, and 10 inches. 10 would have to be my C, or the hypotenuse of this possible right triangle. So what I need to plug in is I need to say 5 squared plus 8 squared equals 10 squared. In this case, I have 3 numbers that I can square, so go ahead and square all of them. You get 25 plus 64 equals 100. Well, 25 plus 64 equals 89. It does not equal 100, so this is not an identity. It is not a right triangle. B, we have 9 meters, 40 meters, and 41 meters. In this case, 41 would need to be the hypotenuse because it's the longest side, or we need to plug in 41 for C. So I would have 9 squared plus 40 squared equals 41 squared. Well, when I square all of those, I get 81 plus 1,600 equals 1,681. And that is clearly going to be true. Now, when you have a multiple choice question, go ahead and just make sure that you're happy with your answer B, because so far B does work and could be the side lengths of a right triangle. Double check yourself. And something that I want to point out really quickly, as we start C, which would be 5 squared plus 12 squared equals 17 squared, if you were just adding the numbers and not using the Pythagorean theorem, not adding the sums and setting it equal to the hypotenuse squared, then 5 plus 12 does equal 17, but if you look when we apply the Pythagorean theorem, 5 squared plus 12 squared, 25 plus 144 does not equal 17 squared, 289. So they're trying to trick you with C, because when you don't square them and you just say 5 plus 12 equals 17, that's true, but that's not the Pythagorean theorem. That doesn't tell us that it's a right triangle or not a right triangle. So just be careful and don't let them kind of trick you. That's something that you'll see a lot, is an example like C, but that is not a right triangle. And then D, 17 would have to be the hypotenuse, so we're going to have 8 squared plus 14 squared equals 17 squared. When you square them all, 64 plus 196 is not going to equal 289. So I am happy with my answer B. So my final answer is B. 9 meters, 40 meters, and 41 meters. Those three side lengths do form a right triangle. Today's assignment is on page 629. It's numbers 6 through 20 all.